In the boundless silence of space, propulsion is a problem. No air, no wind, no friction, and no way to push off from anything. In this weightless vacuum, movement comes at a cost, a heavy one. Chemical rockets burn fast and burn out quickly. Ion drives sip power more efficiently, but still depend on fuel. But what if there were another way? A way to travel through space without fuel, without fire, without noise. A spacecraft propelled not by combustion, but by light itself. This is the promise of solar sails, vast, shimmering structures that catch sunlight like ships catch wind. An ancient idea made real by modern science. A quiet revolution that could change the way we explore not just our solar system, but perhaps one day, the stars. Light travels at 300,000 kilometers per second. It has no mass, and yet it carries momentum. That momentum, when it strikes a reflective surface, exerts pressure. Tiny, yes, incredibly faint, but in space, where there's no resistance, even the gentlest push can have powerful consequences. A solar sail works like this. A vast, mirror-like sheet reflects sunlight. With every photon that bounces off, the sail receives a tiny kick. That kick is constant, endless, and over time, it builds speed. The larger the sail and the lighter the payload, the more efficient the push. A spacecraft propelled by light doesn't start fast, but unlike rockets, it doesn't stop accelerating. There's no fuel tank to empty, no engine to fail, just constant thrust provided by the most reliable engine in the solar system, the sun. A billion photons striking every second. Long before solar sails became science, they were science fiction. The first whispers of this technology came from visionaries like Tsiolkovsky and Sander, who, as early as the 1920s, wrote about spacecraft pushed by the pressure of sunlight. In the 1960s, the idea captivated Arthur C. Clarke, who imagined elegant space yachts gliding on solar wind. Clarke believed these vessels could race through space, silent and majestic, forever powered by the stars. But perhaps no one championed the idea more passionately than Carl Sagan. On national television, Sagan described solar sails as one of the most beautiful ideas in spaceflight. Not a rocket, but a sailboat in the void. He imagined great silver sails flying toward distant stars, driven only by light. At the time, it seemed fanciful, a dream. But like so many dreams born in the imagination of scientists and storytellers, it would not stay there for long. For decades, the idea of solar sailing floated in the theoretical, elegant in principle, but trapped by technology. That changed in 2010, when Japan's Ikaros became the first spacecraft to successfully deploy a solar sail in deep space. Ikaros wasn't just a test, it was a mission. A sail, 14 meters wide and thinner than a human hair, unfurled in the darkness, reflecting sunlight and quietly accelerating. It didn't rely on rocket fuel. It simply rode the sunlight, slowly changing its path as it drifted toward Venus. The experiment was a triumph, and it proved that light, and light alone, could be used for interplanetary travel. Inspired by Sagan's vision, the Planetary Society followed with its Light Sail project. With support from private donors and space enthusiasts around the globe, the nonprofit organization launched a compact CubeSat with a sail 32 square meters wide. In 2019, LightSail 2 successfully raised its orbit around Earth using nothing but sunlight. It was small, modest, but historic. A solar sail spacecraft is unlike anything else in the sky. Forget engines. Forget fuel tanks. These are spacecraft built around fabric, razor thin, reflective, and impossibly delicate. Most sails are made from mylar or captain, coated with aluminum to maximize reflectivity. Their thickness? Often less than 5 microns, thinner than a plastic grocery bag. The sail must be folded to fit into a launch vehicle, a process that's more origami than engineering. Then, once in space, it must unfurl perfectly. No tears, no snags, no folds. A single flaw could doom the entire mission. Controlling the craft is done by tilting the sail, adjusting the angles so photons strike it just so, allowing the spacecraft to steer. It's not easy, it's not fast, but it is breathtaking, because once deployed, the sail becomes a floating mirror, a gleaming square or circle gliding across the void, powered by pure sunlight. A ship made of light. Solar sails aren't just novelties. They are tools, and soon, they may be essential. Missions are already being planned to use solar sails to visit asteroids and comets without using heavy fuel, position observatories at stable, distant orbits from Earth or the Sun, monitor solar activity from angles unreachable by traditional spacecraft, survey the outer solar system, including missions to Jupiter's moons, the Kuiper Belt, and beyond. Because the further we go, the more fuel we would traditionally need. But with solar sails, we don't need to carry fuel at all. Instead, we carry patience. Let the sunlight do the pushing, slowly, steadily, across millions of kilometers. But perhaps the most audacious vision of solar sailing isn't within our solar system. It lies far beyond. In 2016, physicist Stephen Hawking, along with Russian billionaire Yuri Milner and Facebook's Mark Zuckerberg, announced Breakthrough Starshot, an initiative to send tiny spacecraft to Alpha Centauri, the nearest star system. The plan? Equip microscopic probes with ultralight sails and blast them with Earth-based lasers, accelerating them to 20% the speed of light. These tiny craft, no bigger than postage stamps, could reach Alpha Centauri in just 20 years. That's faster than anything humanity has ever built. Far faster than any chemical rocket could ever achieve. It would be the first interstellar message in a bottle, carried not by engines, but by light. Of course, solar sailing is not without obstacles. Sails are vulnerable to micrometeoroids, to cosmic radiation, to thermal extremes. Deploying them in space requires incredible precision. And for laser-driven interstellar sails, we still need the infrastructure. Massive ground-based lasers, accurate targeting systems, and navigation technology that doesn't yet exist. But the challenges are shrinking. Every year, materials improve, designs evolve, missions succeed, and bit by bit, the idea once scrawled in the margins of physics textbooks and sci-fi novels becomes reality. We are learning to sail, not on oceans, but across stars. The first explorers crossed seas in wooden ships, guided by stars and driven by wind. Now, we prepare to cross space in sails of polymer and light, guided by mathematics and still driven, in a way, by the sun. Solar sailing is elegant, quiet, patient, and utterly transformative. It's not just a new way to move. It's a new way to think about movement, about distance, energy, and possibility. And in the centuries to come, when humanity sails among exoplanets and navigates between stars, it may be these early sails, fragile, fluttering, and bold, that history remembers as the moment when we first let go of fire and caught the wind of light.